Hey everybody, today we're going to jump right into the second session of the 2015 Mcas. This is the calculator session, so you can use a calculator during this. The idea is that you would try this on your own and then watch this video, so you shouldn't be watching this unless you've already tried these. And the whole purpose of this is to try to get more exposure to some of the Mcas problems from the previous edition. These are significantly different and usually a lot easier than the current edition, but there is some value, I think, still in doing these. Okay, so let's jump right into it. Ethan poured orange juice into each of 4 glasses and estimated that each glass contained 8 ounces, rounded to the nearest ounce. Based on Ethan's estimate, which of the following could be the actual total amount of orange juice in the 4 glasses? And we're given 4 different values here. So some key words here: rounded to, the nearest ounce, and estimate. So this is really asking us if we can take 4 glasses, and we know they each round up to 8 ounces, right? Each one. What could the total possibly be? So this really requires you to know how rounding works. So we know they round to 8. So it could be as high as 8.4 or 8 4/10, or as low as 7.5 or 7 5/10. Because each of those would round to 8. I'm going to close this door actually, guys, because the next door teacher is being kind of loud. Hold on. Okay, there we go. Let's try that out now. So we know that the lowest it can be is 7.5 or 7.5. Let me turn this so it's not crooked. There we go. The lowest it can be is 7.5, and the highest it can be is 8.4. So we're going to find the low and the high. So we know there's 4 of them. So let's see what it would be if they're each 7.5, right? 7.5, 7.5, 7.5. So we're going to find the lowest possible value. And we can use a calculator, so let's make our lives easier. 7.5 times 4, and that's 30. So as low as 30, that's the low. Okay. Now let's find out what they would be if they were 8.4. Okay. Let's find out what that is. So 8.4 times 4, and we get 33.6. Okay. And that's the high. Okay, so let's see here. Let's look at our potential answers here. 28 ounces, that's too low, that's out. 29.6, that's too low, that's out. 31.6, well, that's right in between that range, so that's looking pretty good. And then 34 is too high, so it has to be C. Okay. Number 23. 4 equations are shown below. E plus, okay, well, I'm not going to read these, but you can see this. Basically, we have addition, subtraction, multiplication, division, and we're changing the order of these variables. Which of these equations are true, how many of these equations are true for all real values of E and F? This is simply asking you if you know your commutative properties. Okay, the commutative properties when you change the order of something. So, is E plus F equal to F plus E? Yes, because addition is commutative. And you could, if you weren't sure, you could plug some numbers in. Like, let's say E is equal to 1, and F is equal to 2. Well, guess what? We could try that. 1 plus 2 is equal to 2 plus 1, right? Subtraction, though, is subtraction commutative? No, it is not. 1 minus 2 is not the same as 2 minus 1, so that's out. Is multiplication commutative? Yes, it is. 1 times 2 is the same as 2 times 1. So we have 2 so far. And then division. E divided by F is equal to F divided by E. No, it is not. 1 over 2 is not equal to 2 over 1. Division is not commutative. So we have 2 equations. Okay? What we got here? On the line graph below shows the change in population of the state of Ohio in 20-year intervals from 1900 to 2000. Okay? During which interval on the graph did the population of Ohio increase at the fastest rate? So this is really asking us if we know how rate of change works. Okay, and how it can be displayed graphically. So each of these segments is a 20-year span. So from 1900 to 1920, the population of Ohio went from just over 4 million to we're almost right at 6 million. So almost 2 million increase in 20 years. It's pretty significant. And you can likewise check here. Now what you could do, you could try to estimate these points and use the slope formula. Like you could do, m equals y2 minus y1 over x2 minus x1, and kind of estimate the rate of change and find out which one's higher. You don't need to do that, though. There's a much quicker way of doing that. You just look at each of these segments, and you see which of them is the steepest. Because the steeper the slope, the higher the rate of change. And this is the steepest slope. If you look at it graphically, this is the steepest one, right? So this is definitely the highest rate of change. You can tell if you were to mathematically estimate it. This is right around 7 million, because this is 8, 6, almost in the middle. 7 million to just under 10, so it went up by right around 3 million. Okay. So it's asking us for the interval. So this interval is 1940 to 1960, which I believe is letter C. Okay. Let's look at number 25 here. A water tank in the shape of a right circular cylinder has a height of 40 feet and a radius of 15 feet, as shown in the diagram below. Here we go. Based on the diagram, what is the volume in cubic feet of the water tank? So this is asking us for volume, and we have volume as part of our formula sheet. Let me find that real quick. So at the end of the PDF, this is the formula sheet. So we're going to look for volume of a right circular cylinder, which is right here. So V equals pi r squared times h. So I'm going to write that down here. V equals pi r squared times h. What is the volume in cubic feet of the water tank? So let's see if we can assign these variables. So we have r squared. R is radius, which is the distance from the center of the circle to the point on the circle. So radius is going to be 15 feet. So we're going to have pi times 15 squared, and then times the height, which is 40. So this is really just asking us if we know how to do order of operations, really. So we're going to do exponents first. 15 times itself, I believe, is 225. Let's see. 15 times 15, 225. So we have pi times 225 times 40. And then 40 times 225. I think that's 9,000, I think. Let's see. 25 times 40. 9,000. So we have 9,000 pi. Now we can change the order of this because, like we saw in the previous problem, or 2 problems ago, multiplication is commutative. So pi times 90 is the same as 90 pi. And we're going to leave it in terms of pi because that's actually the most accurate way of representing pi. Once you start to round it, a lot of people think it's, 3.14. It's actually not. That's just an estimation. All right, number 26. The circle graph below represents the number of cars in a parking lot and their colors. So this is the actual numbers of cars. This is not percentages. If 25% of the cars in the parking lot are white, so white is 25%, which it looks like actually. It looks like a quarter of this pizza. How many cars are silver? All right, so we're looking for this as a percentage. Oh, sorry, no, we're looking for the actual number of cars. All right. So looking for the amount of cars that are silver. So let's see here. How can we do this? Let's find out what the total number of cars is. Let's just do that. So if 50 is 25%, so 50 over x equals 25%. Let's find out what this is as a number. So we're going to say, no, hold on a second. Is that what I want to do? Yeah, let's try that way. So we're going to multiply both sides by x. And actually, to change it to a decimal, of course. What am I thinking? So it's going to be 0.25. And then we're going to multiply by x. We're going to have 50 equals 0.25x. No, that's not right. Yeah, I think that's right. We'll figure it out in a second. Sorry, brain's still waking up here. Divide both sides by 0.25. Let's see what we get. 200. Yeah, that's right. Okay, good. Brain was like figuring that out. All right, so we're going to have the total number of cars is 200. What happened there, guys, I was actually forgetting to convert that to a decimal, so that's why I got a little confused there. So there's 200 total cars. All right. What we can do now is add all these together and subtract that from 200, and the remaining value will be how many silver cars there are. So first thing we did was we knew this is 25%, so we use that to find out the total, and then we'll subtract all these other values to find out what the remaining silver is. So let's see. So let's add these together. So we have 50 plus 24 plus 36 plus 20 plus 38. Let's just double check that. 1, 2, 3, 4, 5. 1, 2. Yeah, that's okay. Let's add these up. I'm using my calculator. Oh, well, no. 10, 18. I'm using a calculator for this. 6, 8, 11, 13, 16. Let's just double check that with the calculator. Since we have it, might as well use it. Oops. 50 plus 24 plus 36 plus 20 plus 38. And we get 168. Yep. So there's 168, not including this. So subtract this from 200, and we'll find out how many silver cars there are. I believe that's 32. Wait, what am I doing here? Yeah, it's 32. Okay. So 32 total cars, well, 32 silver cars, rather. There you go. 32. And if I add that all up with this, it should equal to 200, which it does. Okay, cool. Let's see what we got next here. 27. Which of the following scatter plots is most likely to have a line of best fit with a slope of 5? Let's zoom out a little more so you can see the whole thing. Hold on a second. There we go. Line of best fit with a slope of 5. Okay, so it's kind of hard to see when I zoom that far out. So slope of 5, first of all, we know it's a positive 5. So we know positive slopes are going up from left to right. So this is out. And this is a flat slope. There's actually no slope. It's called 0 slope, so that's not 5. This so far is the only one that's positive, and this is undefined, so it has to be C. Yeah, pretty straightforward with that one. Line of best fit would be the line that best represents the data. So if you draw lines that best represent this data, you can kind of see here. All right, number 28. Two families buy refreshments at a concession stand. Each drink costs D dollars. Each snack costs S dollars. The Blake family buys 3 drinks and 2 snacks for $12. The Reese family buys 2 drinks and 4 snacks for $16. What's the cost of 1 drink? Okay, so this is a systems equations problem. So we're looking for the cost of D. All right, so D stands for dollars. D stands for drinks. S stands for snacks. So we'll do the Blake family equation. Blake family equation is going to look like this. We're going to have 3 drinks, so 3D, plus 2 snacks, plus 2S, equal. I hate when they have S as a variable because it looks like 2. If you read it, kind of sloppy. And that equals $12. And then the Reese family, 2 drinks, so 2D, and 4 snacks equals 16. All right, so how do we solve this? I would do elimination. I prefer that. So we're going to eliminate since we want to get D by itself, we're actually going to eliminate S. And I want to make this I want to make these cross each other out, basically. So what you could do is multiply this whole equation by 2, this whole equation by 4, and cancel it out. I'm going to make it a little easier, with a little less work. I already know this can become 4, so I'm not going to multiply this equation by anything. I'm going to multiply this by -2 because I want this to become -4 so they cancel out. But you can always just multiply by the other equation's coefficient and make sure they have different signs, and that will result in elimination. This way it actually requires less work. So as long as you have the number sense to see that, you can do it this way too. -6D minus 4S equals -24. The reason we're multiplying by a negative is because they have the same sign, so we want them to have opposite signs, so they end up canceling out, or eliminating rather. So 4S equals 16, and now we just combine these together. So -6D plus 2D is -4D. These cancel. And then -24 plus 16 is going to be -8. So now we're going to divide both sides by our coefficient, which is -4. And D is going to be equal to +2. So drinks are $2 each. Which is right there. Okay. And let's look at number 29. This will probably be the last one before we take a break, I think, yeah. So the first term in the sequence is 24. Each term in the sequence after the first term is equal to half the previous term plus 4. Which of the following statements best describes the terms in the sequence as it progresses? So let's just do some test terms out here. So 24 is the first one. Now the next term is half of this plus 4. So half of 24 is 12, plus 4 is 16. Okay? Half of 16 is 8, plus 4 is 12. Half of 12 is 6, plus 4 is 10. Half of 10 is 5, plus 4 is 9. Half of 9 is 4.5, plus 4 is 8.5. Half of 8.5 is 4.25, plus 4 is 8.25. Okay. So you can see the amount it's changing by is significantly going down. Okay. Terms get closer to 8. Terms get closer to 12. Terms increase at a constant rate, terms decrease at a constant rate. Okay, so we can immediately eliminate these. This is not a constant rate of change, right? This went down by 8, then 4, then 2, then 1, then a half, then a quarter. So these are both out. Okay. Are they getting closer to 12? Absolutely not. It's going away from 12. In fact, it's getting closer to 80. You can see from left to right. So this becomes a lot easier as long as you're able to do this calculation. Let's see, 1, 2, 3, 4, 5. We did it 6 times. You wouldn't even have to do that. Probably just 5 times is probably enough, or even 4 times, because you see it goes past 12. And as long as we know what constant means, we should be able to at least get this down to a 50-50 shot. Okay. All right. So before we stop, let's just check our answers and see how we did. So let's see here. Let's start with number 22. Zoom out a little bit. So 22, we got C. So 22, we got C. We got that right. Cool. 23 is B. Let's see if that's right. 23 is B. Nice. 24 is C. 24 is C. All right. So far, so good. 25, we got D. 25, we got D. 26 is A. 26 is A. And then 27, we got C. 27, we got C. Okay. 28, we got A. 28, we got A. And the last one, 29, we got A. And 29, we got A. Okay. So not bad, not bad. So we got a few there, and I'll try to continue making these during the week, guys. All right. Thanks.